All right, A3, T61, A03. This time we're going to try to plot some conditions because in this particular question, we're asking from the psychrometric chart, what is the volume of air leaving the coil? So let's switch over to the psychrometric chart and just review the different pieces of information on the psychrometric chart that are useful to us. So basically, to use a psychrometric chart, you only need two conditions of air, any two conditions of air that are plottable, and you can interpret all kinds of other information about the air from the chart. For instance, if you know the wet bulb and dry bulb temperature of air, from that you can determine its specific volume, its relative humidity, its BTU content, etc., etc. So let's just break down some of the components of the chart. I'll switch over to a highlighter and we'll see a lot of lines intersecting each other. But the lines that are interesting to us, first of all, are down here on the bottom horizontal scale. Let's highlight all this here. On that scale, we have and I can expand and decrease here a little bit, that's our dry bulb temperature, right? So if you know the dry bulb temperature, you know that these vertical lines all represent dry bulb temperature for air. So we have 25 degree dry bulb temperature, 30 degree dry bulb temperature, 35, 40, 45, and so on and so forth. Take those out. Dry bulb temperature for air is very important. What else do we have? We have wet bulb temperature for air. Wet bulb here. Now the wet bulb temperature for air are diagonal lines that are moving from sort of top left to bottom right. So here would be some wet bulb temperature for air lines, and these are lines where the wet bulb temperature is constant anywhere on the line that you plot your data. So this would be, for instance, 30 degrees, 35 degrees, 40, 45, 50, and so on and so forth. Those are your wet bulb temperatures, and you can get your wet bulb temperature by using a sling psychrometer. You can measure the wet bulb and the dry bulb temperature of air using a sling psychrometer. And actually from a sling psychrometer, you can also calculate your relative humidity. And relative humidity lines are also here on your psychrometric chart. And they are, measured in percentages. So here we have relative humidity. See that right there, relative humidity. So for instance, this curved line here represents a constant 10% relative humidity. So if you were to plot or measure that your air is 10% relative humidity, it could end up anywhere on that line. And then just above it, we have our 20% line, our 30% line, our 40% line, 50, 60. Of course, it goes on and on and on, all the way up to 90. And in fact, always gets all the way up to this top curved line here, which represents 100% relative humidity. At 100% relative humidity, you have a complete saturation of wet bulb air in the sense that it's going to be raining, right? The air cannot hold any more moisture. So there's some interesting lines for us that we're going to take a look at. What else do we have here? We have the enthalpy of the air, right? What's enthalpy? How many BTUs of heat energy per pound of dry air is there? And so we have this entire scale here representing enthalpy, and the enthalpy could be, along here, which would represent 10 BTUs per pound of air. You got to remember that a psychrometric chart is always talking about 1 pound of air, 1 pound of air. And then you have 15 BTUs per 1 pound of air, 20 BTUs, 25, and so on and so forth. So there's your enthalpy. And we have the specific volume of air, right? In other words, if your air has certain characteristics of wet bulb, dry bulb, relative humidity, et cetera, we can also infer from our psychrometric chart how much volume of space 1 pound of air will occupy. And here are some numbers here. For instance, this line here represents 14 cubic feet per pound of dry air. And this line represents 13.5, and this line represents 13.0, and you can interpolate anything in between adjacent lines on the chart. So for now, those are some very interesting aspects of the psychrometric chart, just to have familiarity of where to get information from the chart. There is other information on the chart. It's not relevant to the questions that we're asking in this particular exercise, but you can calculate, for instance, pounds of moisture per pound of dry air, grains of moisture per pound of dry air, and that's on these scales here. So you can just move from left to right and intersect this far right vertical line to calculate, how much actual measurable moisture is in air. But now let's get back to the question at hand. So we're going to clean up our drawing, reframe it here, and I think we're going to actually plot the process that we're interested in. Because what is our process? Well, our process, if we go back to the question, our process has air entering a coil and leaving a coil with changing conditions. So why don't we actually plot that movement, right? We need two pieces of information to plot the conditions of the air entering the coil and two pieces of information to plot the air leaving the coil. So entering the coil, I'm going to underline here again, entering the coil, we had 75-degree dry bulb, 50% relative humidity. So 75 and 50. So let's find where those 2 points intersect on our psychrometric chart. And we can plot the state of the air as a single point on the chart where it enters the chilled water coil. So 75-degree dry bulb is going to be right down here. I'm just going to point that out right here, 75-degree dry bulb. So I'm going to carefully follow that line all the way up to where it intersects with a relative humidity of 50%. And my 50% relative humidity is not that hard to find because 50% is right there. There's your 50%. And there's my 75 degrees. So we're just going to bring those two together until they intersect. And if you bear with me, I will overlap now with my ruler and we'll draw some lines. So here we go. In fact, I might just expand that just a little bit so that's a little easier to see. So there's my 75. You can't see this, but my ruler's right on the 75. And there's 50. And I'm just going to put a dot right there. All right. There's a dot right there. Now, we don't want to be confused with this other dot on the page. So let me just get rid of that dot. Okay. So right here, right there, this is our entering air condition. Okay, our entering air condition. And you can see from that dot, all we have to do is infer all kinds of information. I can infer how many, BTUs per pound of dry air are in that pound. I can infer grains of moisture. I can infer wet bulb temperature. I could just go on and on and on. So we just needed those 2 points. Now, what about the leaving conditions? Let's get rid of that arrow. The leaving conditions were that we cooled the air to 55 degrees. So let's move this around, right? 55 degrees is there. And 95% relative humidity. So we've actually picked up tons of moisture. So 55 and 95. Now, 95 in terms of relative humidity is between 90 and 100. We can clearly see the 90% line and the 100% line. So I'm just going to have to estimate in between those two lines, as they come down here. And I'm going to be drawing a line somewhere up here. We're going to be somewhere in here, right? But let's use a ruler and make sure it's very, very, very straight. Okay, I'll take my time now. So 55 and 95. I'm just going to assume 95 is right about there. There's my dot. Okay. So I have air entering the coil at position 1, air leaving the coil at position 2. And if I wanted to draw that as a process, I can connect the two with an arrow like this. Right? And I can say there's my actual process right there, right? From 1 to 2. Now the question's saying, what is the volume of the air leaving the coil, right? Let's go back to the question. What is the volume of the air? The volume of the air leaving the coil right here. So we're going to find the data point we plotted at position number 2. Okay, position number 2. I'll take out the arrowhead now. I might even take out The 1 and the 2. No, we'll leave the 2. And all we're going to do is interpret the specific volume of the air leaving the coil from that point. Well, we got to find our specific volume lines. Let's remember now, here's a specific volume line of 13. Here's a specific volume line of 13.5. And, you know, my point number 2 right here is somewhere between those two purple lines. Where is it between the lines? It looks pretty close to about 13.2 cubic feet per pound of dry air. Let's look at our answer choices. In our answer choices, we have, let's look at them one by one here. We have A, 11.2. Can't be 11.2. We're definitely above the 13 number. There's 13.2. I mean, that's looking really good. And these ones here, 14.2 and 15.2, look way too far off. So the only correct answer, right, is going to be 13.2. In other words, if I was to go back to my plot, what I'm saying is with the purple line, position number 2 right here represents a diagonal line of about 13.2, which puts me halfway between 13.0, a little under half, and 13.5 in terms of specific volume. So once again, the correct answer is interpreted from the data point representing the leaving conditions of the air on your psychrometric chart and just interpreting the specific volume from that point, which was point number 2 in our process line from 1 to 2.